Hello everyone. Welcome to our webinar, Matching Hydraulics to Agronomy. My name is Rolf George. I'm the Senior Global Product Manager for Tapes at Rivulus. Great. So we're going to have an overview of, irrigation agronomy. By introduction, we're going to understand the importance of the grower's perspective here. We're going to look at optimizing crop performance here, talk a bit more about designing a favorable outcome for our customers. Then we're going to take a dive into crop monitoring. And here I just want to touch base with you folks to show you what it looks like from the grower's perspective. How do they spend every day growing the crop and what they have to contend with? And then we'll move into choosing a lateral, making decisions based on the needed attributes, and also take a deeper look at installation considerations, which can impact the performance of the system greatly. And then we'll have a brief summary. Then I'll share with you folks some of the Rivulus resources that are available on our website. And then we'll move into a Q&A session. That said, I'd like to encourage you as we go through this presentation, please feel free to post your questions. My colleague Romeo Dragan, he's our moderator here, and he's going to assist us putting that together at the end of the session. So kicking it off with the irrigation agronomy. So this is about matching hydraulics for agronomics. And what we're talking about here is first and foremost understanding what gives the return on the investment for a grower. So clearly the key drivers here are yield and quality. And again, the irrigation system design accountability should enable us to apply optimum moisture to the plants. And we need to ensure that we're matching the hydraulics to accomplish the agronomics throughout the crop cycle. In terms of the irrigation system preferences, we really want to be focused on delivering required soil moisture distribution uniformity. And of course, at Rivulus, we do that very cost effectively with closer emitter spacings. The hydraulic design should have full operational capabilities, enabling us to do the back flushing, do the lateral flushing, and so ensuring that the design is beyond just putting water or applying water to the plants. Some of the critical success factors that we need to consider here, understanding the crop requirements, what are the target yields, what are the quality requirements for the grower, things like taste, shelf life, bricks, etc. And then understanding the interaction of soil moisture content, nutrient interactions, and the soil infiltration rates and percolation rates in the profile. So the impact of the irrigation system choices we make should deliver irrigation proficiency to meet these crop requirements and designing for seasonal longevity for high performance. So from the time we put the seedlings in the ground until we go to harvest, we want that system to deliver the required and designed performance. So putting it all together, we want to be focused on, as industry professionals, good system designs that meet the crop requirements during the respective phenological growth stages. We want to be able to do the irrigation scheduling. So this is the how much and how often. And, typically we'd say little and often. But we want to really understand and translate it into what the plant needs. And then in terms of system maintenance, we have to ensure that the integrity is there, but not at the expense of plant water demand. So not cutting short on designing the system. In terms of irrigation scheduling, again, the different growth stages, developing the roots initially, getting the flower stimulation going, setting the fruit, filling the fruit, and then the early pre-harvest strategies and soil moisture and cation balance or nutrient balance all play an important role in all of this process. So the grower's goal essentially is to deliver good quality and profitable produce to the market. So in terms of optimizing crop performance, clearly high value, high risk. So some of the important considerations when investing in drip is for us as professionals to understand the crop requirements according to the grower best practices. So what do they need to be able to do to get the most out of their plants and their crops. And equally, what are the market requirements? What are the quality drivers that they need to perform to ensure a good profitable outcome? The interaction of soil, water, and nutrients, they impact yield and quality. And a big component to being successful is understanding the soil moisture distribution uniformity. So therefore, we want to mitigate the risk by being able to apply water to the crop on demand, scheduling for optimum soil moisture content, and then also including the ability to apply fertigation to sustain fruit yields and quality. And as we go through this process, we need to measure parameters like in water and soil, the pH, soil moisture measurements, the electrical conductivity or EC, which is essentially the soil solution ion load and the composition, and so not just the value of the EC. All of these are interactive and very critical for successful crop. So one of the purposes of putting this out here is we've seen in the market trends where competition is fierce. And so we are understanding that more and more systems are being compromised. So when you've got a reduction in irrigation design efficiency, suddenly the grower can't pulse irrigate or they can't fertigate according to the plant requirements when they really need to be doing that. And therefore, we've got system design compromises where it's inadequate to get the back flushing done on the filters, flush the laterals. And basically what happens here is we're forcing the agronomy now to fit inferior designed systems. And this is being done because it's cheaper, right? So in this sense, it restricts the ultimate crop performance and it's costing our prospective customers a lot of dollars. So we're trying to understand this and mitigate being in this situation. And very often, seasonal application compromises are considered because of it being a short season or a 90-day, 120-day only. We must always put micro irrigation in the correct context. We're dealing with small apertures. We're pushing water through very small outlets, if you will, as in drippers, discharge rates, as in the amounts. So we really want to be doing that precisely as best we can. And if we make compromises, we have efficiency losses. It's very difficult to measure those as we go through the season. And also additionally, because the grower is just simply too busy, and we'll see a bit of that in a few slides. So when investing in drip, the accountability we as professionals have essentially is to deliver solutions for the customer to achieve their crop goals. And we really want to be able to plan to meet the agronomic crop value requirements, if you will. And so therefore the lateral choice, as in soil distribution uniformity, the placement of the lateral, as in water use efficiency, and then clearly the hydraulic design, so emitter spacing, the flow rates, the diameters, the thickness of the tape or the laterals, as well as the emission uniformities are all integral components of being successful in helping our growers to achieve their growth goals or objectives. In engineering designs, of course, we want to meet the evapotranspiration rates. So we want system proficiency to maximize the drip benefits. So here we want to be able to pulse irrigate when needed. We want to be able to flush those filters when we need to do that, or the laterals. And we also want to be able to meet our filtration standards. So as in the micron or mesh standards that are recommended for those particular filtration systems. Additionally, some of the key resource considerations, it's a very complex science, as in soil, water, and nutrients. So as far as soils are concerned, the classification, understanding the soil type, the chemistry, it's a very complex science, and balancing the nutrients, as in managing the pH and the electrical conductivity, the soil structure, perhaps there's some compaction in there, so testing for that and making sure that the infiltration rates are not affected by that. And in water quality, of course, the pH and the EC are two key components, but not only, there are other considerations, we'll see those a bit later, and also the correct filter choice and filter requirements should be applied. As far as nutrients are concerned, we know that pH has a strong influence in the availability of nutrients, and the EC. Basically here we want to balance the key macro and micro elements, and then also consider, in case of high salinity levels, how to deal with those. So from this, you can understand from the grower's perspective, it's very complex. And therefore, when we're making those recommendations and helping them make lateral choices and configuration choices, we want to make sure that they get the best solution for these given circumstances and parameters. This is just a reflection of soil water holding capacity in different types of soils. So we have to always bear in mind that every soil is different. And so we need to understand, how much water we can truly hold, as in being able to manage the soil moisture levels throughout the different growth stages of the crop. We'll take a deeper dive in that a little bit later, but this is a very important component of helping growers make the right decision. Another phenomenon here, which I like to talk about, is understanding the preferential uptake zone. So in context of the active root zone, what are the levels at which the plant is effectively extracting water and nutrients? And this starts to help us understand things like set times and irrigation frequencies. When we look at this slide, I apologize, it's very complex, but it's not to get into any detail on water analysis and soil analysis, but it's just to give you a reflection of what the grower has to deal with. So when they go out there and they want to grow a crop, they have to do this water analysis, the soil analysis, and put all of these components together to then have a schedule that's going to give them the right mix of fertilizer, water use to grow their crops. pH, of course, we know has a big impact on nutrient availability, and it's one of those critical parameters that we need to pay attention to as well. So the chemistry in the soil and water is, again, a very complex science, and our customers have to deal with that. And in helping them apply the right amount of nutrients, etc., that lateral choice becomes a critical component to their success. Another important consideration here is to exploit the capillary of the soil. So we know that the first force of movement when water hits the soil is capillary. So we need to understand the characteristics of our soils and how does it work for a target field that we want to make a recommendation on. And again, the soil distribution uniformity is critical in terms of understanding the water holding capacity, managing that, the infiltration rates, which eventually will help us understand the set times, so how long to irrigate for. The capillary, the lateral movement, if you will help us understand the frequency. So how often should we be watering? So capillary is the most effective way to distribute water in soils with drip irrigation. Taking this to more of a sales environment, if you will. So when we are recommending a lateral, we find very often, sales folk will confuse soil distribution uniformity with emission uniformities. So how you've got agronomy versus hydraulics. So on the hydraulic side, we can give you a 90% emission uniformity, but we can do that with different emitter spacings. We can give it to you with 16 inches, with 8 inches, with 4 inches, etc. But really what we want to be doing is looking at the soil type, considering what is best for our grower and for our customer, and customize that dripper spacing to deliver the desired soil moisture distribution uniformity as best we can. So in this situation where we have wide emitter spacings or dripper spacings, very often what that results in is that we tend to start to run the system longer, so longer set times. And we're doing this because we're trying to move the water in the soil, down the row. And what happens here is most often is we start to irrigate beyond the active root zone, and of course that results in leaching, which is very undesirable. So by having the right choice of emitter spacings, as you can see here on the right hand side, we can balance our water with gas exchanges in the soil profile and keep it in the active root zone. So we're not wasting water, we're not wasting nutrients, and we're optimizing the moisture content in the soil for the plants. So that said, the consequence of long set times, so extended set times to try and push the water and move it laterally, what happens is we get leaching beyond the active root zone. So there goes the nitrogen, potential contamination of groundwater. And then additionally, we are effectively creating an anaerobic environment around the lateral or the drip tape in the soil profile. And in this instance, we will have a reduction in nutrient uptake, but we'll also have a higher risk of soil-borne diseases, potentially. So it's very important to understand this phenomenon of the impact that when we make a recommendation that dripper spacing, the soil distribution uniformity, and the ability to manage the moisture evenly and consistently in the profile is very important. Soil moisture retention. So first of all, building that that profile moisture bank, if you will, and then maintaining it is also very important to know how to do that and to understand the dynamics of soil moisture movement in the profile. And again, exploiting and utilizing that capillary potential that exists in any soil. So putting all of that together, maintaining the soil moisture throughout the different growth stages, and perhaps manipulating it, even doing some deficit irrigation as needed or if needed. These are all strategies that we can then apply once we have the capability of managing the moisture in those effective zones. So this was just a brief introduction, if you will, in the idea of what it is we're trying to consider here. Now, what I'd like to do is just to take you on a brief journey into the grower's daily life, right? So what is it they've got to deal with? So obviously, they've got to manage the crop and they've got to monitor. So in doing so, this is what their daily dashboard would look like. They would have to contend with making decisions on soil moisture content. They would have to be looking at nutrients in the plant, nutrients in the soil solution, and then putting all of this together and understanding the interaction of applying water, applying nutrients, and what that means at different growth stages for the plant. And this is just in a little example of some data where you see the EC below the norm, nitrate dropping off below the norm. This is a clear indication of overwatering. So again, by looking at nutrition data, you can also understand the impact that your irrigation management is having on the plant. Very often we get asked about how many sensors do I need on a field or for my fields. In this instance, we have the concept of a management production unit. Some folk call it a monitoring production unit. But essentially what that is the same soil type, the same variety or hybrid, the same planting date, given 3 to 5 days, depending on the crop type. And then very importantly, the same irrigation and crop husbandry practices. So the MPU concept could be 10 acres, it could be 100 acres for an MPU. But this is more or less the approach that we would apply to determine the measurement points out in the fields. In terms of the plant growth and production, again, the timing of water applications and the amounts can be affected by the different types of hybrids or varietal differences, the physiological development, whether we're trying to push the root system, we're trying to set flowers, we're trying to grow the fruit, we're trying to go for good quality pre-early harvest. So they're not too much or too little, but getting it right. Additionally, the timing of nutrient applications according to the different growth stages. So that seedling establishment, the vegetative growth, the fruit set, fruit fill, and again, the early pre-harvest strategies. And so the fruit size and quality and shelf life impacts the marketable crop value. And so this is where the money is, giving your customer the opportunity to make the right choice, get the right soil distribution uniformity to be able to manage all of these different inputs, if you will, and management practices to be successful. And soil moisture content has a huge impact. Of course, nutrients as in forms, for example, of applied nitrogen, so the ammonium versus nitrate discussion, the electrical conductivity, so EC, and the cation balance when we're filling the fruit pre-early harvest, we're trying to hit our Brix targets and achieve a good tasting fruit and a good shelf life. We're not going to spend much time on this, but just to give you a flavor, of what growers typically use on their properties in terms of monitoring equipment. So first and foremost, a site-specific weather station. In this package, they typically get the Penman Monteith, so the evapotranspiration calculations. They can run degree days for phenological and crop husbandry practices and mapping. You get additional things like delta T for spray conditions when applying different types of foliar applications such as crop protection and or nutrient application. And then soil moisture. Again, this is the heart of our business, right? Understanding soil moisture content throughout the total crop life, but specifically at the different growth stages and how to manage that. So typically we could have a multi-depth probe, multi-depth meaning in multiple sensors going down the profile. And this would help us understand the soil infiltration rates. And from this data, we can start to set the set time, so how long to irrigate for. And then we put one of these probes horizontal to understand the soil capillary and the lateral movement of the water. And this helps us understand the frequency, so how often to irrigate. So these are very important considerations. There are numerous numbers of different types of soil moisture devices out there. We're not going to get into that. But from a management perspective, understanding how the water is moving through the soil and the capillary is very helpful information. From a nutritional standpoint, the PDL SAP analysis is a good indicator, and it's really like a blood sample, right? So it's a real-time analysis of plant nutrient status, and it's dynamic. So you're looking at trend over time, and it helps us understand the nutrient uptake dependent also on soil moisture levels, and also tweaking that into the different growth stages in the plant requirements. The EC analysis of the soil solution, this essentially impacts the osmotic gradient in the soil solution. So it impacts water uptake, nutrient uptake dynamics, and we'll see that a bit later. And then spatial imagery. So there's your NDVI, your chlorophyll, and also plant water content in the fields. And it's good data to understand if there are any anomalies occurring. I like to share this slide. What you're seeing here on this particular view here, you've got 9 different seed corn hybrids. And what we're seeing here is the KC calculated by satellite. So this is the crop coefficient. And what's relevant is not one of these are the same. And this is real data that I've worked with in the past. And it's amazing to consider if you had a grower growing these 9 different hybrids adjacent with the same irrigation regime. In some instances, they could be overwatering, in some or underwatering. So this is a very important consideration to note. From a crop monitoring standpoint, water quality, for those of us who have been in the industry and are in the industry for a long time, we understand this very well. It's one of the critical, let's say, components of success in our irrigation management, if you will, as it has a big effect on nutrient availability, as in pH. Sodium and chloride can affect the soil structure and precipitates. You've got the whole chemigation, fertigation thing there, as well as compatibility. You've got sodium absorption ratio, which can impact soil permeability and percolation, which can lead to a different choice of flow rate. So if you've got soils where you've got permeability that is very slow and difficult, you tend to look towards a lower flow type solution. Then additionally, you've got elements in there that could result in precipitates and potentially clog the system. So of course, we're not going to get into all this detail, but I just wanted to give you a reflection of the significance of that. And the same for EC in the soil solution. So our electrical conductivity measurements, they vary. And as you can see, it also has a lot to do with the soil moisture status. So we're not going to go through all the detailed discussion here. But again, I just want to give you a reflection of the significance of managing EC in the soil solution. And here, just to really make my point, if you will, here's some soil moisture data. You can see the stepping here. That's clearly root activity. And then what you're seeing here, after this one irrigation event, the single day plant water use is almost equivalent to 4 days on this side here. And the difference is the tipping point in the EC in the soil solution. So by having made this irrigation here, we've tipped the scales. So you've got a lot more water going up into the plant. This is relevant because if we have low EC, we're going to have increased water uptake, we're going to have cell expansion, we're going to have poor tasting fruit, shelf life. So if you're finishing up a crop, you wouldn't want to be in that situation if it's field or processing tomatoes, strawberries, etc. If the EC is high, of course you'll reduce the water uptake, but then you'll have higher Brix or sugars in the plant or in the fruit, and you'll have good cation uptake, and that can give you better tasting fruit, longer shelf life, etc. So this is all very important to comprehend when we're thinking about, again, uniformity, water uniformity in the soil. It's very, very important. So just staying with the EC discussion, if we control EC using dry stress or prolonged dry stress, what's going to happen is we're going to reduce the yield, we're going to reduce the size of our fruit, but we will have good tasting fruit. The same as if we use high salinity, so just big loads of fertilizer without understanding, balancing those nutrients, we could have a similar result. So lower yields, smaller size fruit, and we would have good tasting fruit. Whereas if we give our customers the opportunity to control the EC with balanced fertilizer applications, they can improve their yields, they can have a good market-sized fruit, and they can have good tasting fruit, good shelf life, and high Brix, etc. So this is a very important phenomenon, if you will, or concept to consider when we're trying to help our growers do a good job and achieve their production goals. PDL SEP analysis, we're not going to go into the detail of this, but I just wanted to put this in there. Again, if we think about our prospective customers, they're trying to measure plant nutrients. The PDL is a good way to understand, real-time data or elemental content in the PDL SEP. And of course, it's a protocol. So it means there's a methodology, if you will, on how to do that. And that has to be followed strictly. But what's important about PDL SEP analysis is the interpretation. So when we look at our macronutrients, for example, and we look at those little yellow rectangles, how often soil moisture content impacts the actual nutrient content in that PDL SEP, it just reflects the significance and importance of why we need to pay attention to these, how much moisture to apply and when to apply it. The same for the microelements. So of course we're not going to go through all this; it'll take way too much time. But again, they're also impacted by soil moisture content. So in essence, we just really reflecting here the significance of managing soil moisture content and the outcome for our prospective customers. Also, if we're overwatering or underwatering, we can see how from the SEP analysis that is impacting the nutrient uptake. So very often, even without soil moisture sensors, by looking at this data, you can understand if a grower is overwatering or underwatering. So what I'd like to do now is just move a little bit into the soil moisture dynamics to wrap up our crop monitoring discussion here. So when we talk about soil moisture content, we talk about agronomic thresholds. We really want to understand the budget lines that will provide the baseline, if you will, for growers to work with to grow their crops. So obviously the readily available waterline, or the onset of stress, if you will, is at the bottom of this blue zone here in the orange, and then the refill point. This is effectively the point at which we'd want to replenish, and this is defined by the active root zone, right? So we don't want to be irrigating beyond the active root zone. And so again, these concepts and budget lines depend on the phenological growth stage and what the actual strategy for that might be. And taking it a step further, of course, if we have luxurious amounts of water going into the soil, we're going to proliferate vegetative growth. We're going to have lower sugars in our fruit. And as we start drying or moving towards the drier end, if you will, or less moisture content, we start to slow down the vegetative growth, and we'll start to increase our sugars, phenolics, etc. So again, this ties into EC. So the drier, the higher the EC will be, and it'll reduce the water uptake. If we have low EC, we'll have high water uptake by the plant. So for the different growth stages, it's important to understand these dynamics and then have the ability, by choice of a good irrigation solution, if you will, what is the best way to manage the crop for that specific growth stage. And then taking it a step further, how does this affect the ultimate goal, which is fruit quality? If we assume, fresh tomatoes, industrial tomatoes, strawberries, etc. So if we are giving luxurious amounts of water, effectively what we're creating here is cell expansion. So we're going to have large fruit, poor taste, low Brix, reduced shelf life. If we can manage the moisture pre-early harvest in this lower zone of the blue, still within the blue zone, so available moisture, but in the lower zone, we start promoting cell division, good tasting fruit, high Brix, longer shelf life. So if you're thinking of ornamentals, or you're thinking of processing tomatoes and Brix, or good tasting fresh tomatoes, strawberries, it's very important. Strawberries are very complicated because there's a lot going on. You're trying to, with strawberries, keep the foliage healthy. You're trying to flower, you're trying to set fruit, you're trying to grow fruit, and then you've got all this pre-early harvest strategy to pick the fruit and have good tasting fruit with a good shelf life. So it's an extremely complex science, if you will. And clearly, if you have data, if you measure, you can manage. So that's one consideration. But from a hydraulic standpoint, again, by closing in on those emitter spacings, improving soil moisture distribution uniformity, this helps us accommodate all these agronomic requirements. So all that said, what I'd like to do here is discuss the lateral choice. So what product works well for these situations? So at Rivulus, T-Tape is our flagship product. It's come a long way. We're talking about decades of success. It's our leading product globally by far, and we're very committed to ongoing research and development, and continue to improve our product over time. And we have found that the appreciation by growers worldwide is extremely high, and we're proud about that. So T-Tape will perform well on the surface or subsurface. The subsurface is successful primarily because of the slit outlet, and we'll talk a bit more about that later. At the same time, from the grower's point of view, being able to have those close emitter spacings, good crop uniformity, leading to good yield performance is clearly a benefit. And very important, we have multiple configurations of different flow rates, diameters, etc. So we can match pretty much any situation out in the field for our prospective customers. And on the other hand, the integrated emitter or integral emitter, it's a seam down the length of the tape. It's very robust, so it assists us for easy installation and also for retrieval. From the grower's perspective, as we've been talking, with high value vegetables and fruit crops, they really want to have good uniformity. And I'm talking about soil distribution uniformity and respective plant performance. And we are able to give them that with the close emitter spacings at no extra cost for the benefit of having that improved uniformity. The system works with low pressure. It'll work also surface or subsurface with those same pressures, and very long row lengths in relative terms in a non-PC configuration. And then, of course, all of this put together gives us very low operating costs compared to other solutions. From the grower's perspective, again, they're looking for reliability. They want to have clogging resistance. They want to get that good uniformity out there. They want to have good seasonal performance from seedling all the way through to harvest. And then they also want to have a product which is easy to install, easy to retrieve, with configurations that match their specific conditions. The integral emitter, so again, because of the way it's built and assembled, you're not paying more for those closer dripper spacings. So that's very different to inserted emitters. You have less risk during the installation and retrieval because of that double layer, if you will. You have multiple options on flow rates, giving us the capability of adjusting for specific types of soils. So it's really considered a robust and stronger product because of this seam and assembly that we have with the overlap. In terms of inlets and flow tracks, we have a very wide flow track, so there's really no restriction of size, as in the case of the emitters. We have a very large number of inlet filters in the emitters. I'll show you a bit more about that. And then the slit outlet for protection from outside. So if there's suckback when you're shutting down the system, the vacuum, it'll resist soil ingestion. On the inlet side, here you can see tables, but please just consider you only need 5 working inlets to match the hydraulic characteristics of the configuration in discussion. So in all cases, we have an excess of inlets, and this really contributes to why T-tape is so popular, from the grower's perspective in terms of clogging resistance. And that's true for any diameter or configuration. On the labyrinth design, I want to highlight to you what's unique here is the labyrinth and the chevron is facing or pointing upstream. So you can see the water flow direction here. The water's coming in through the inlets, down the flow path, out the emitter. With this facing upstream feature, it creates more turbulence in the flow path, and so it'll keep solids in suspension to prevent buildup. And this is very unique, and it's one of the major contributing factors why we have such good plug resistance. The slit outlet it has been a fantastic and very successful innovation from Rivulus over time, and it is effectively a knife cut. So we use a knife blade, if you will, in our production process, and we don't remove any material. So it's truly a slit without removing any material. And that's different to a laser type emitter, which is then effectively it's a slot. It's not a slit. And of course that plays into what we talked about earlier, shutting down the system, any risk of vacuum, and soil ingestion back into the emitter. On the product range, I'm not going to go through all of this, but I'm just giving a reflection here to appreciate, the flow rates that we can offer, the spacings as an emitter spacing. We have multiple tape diameters. And again, when we're trying to customize a recommendation for a given soil type, we can select from these flow rates, from these diameters, and emitter spacings, the optimum solution to give the grower for the given length of run of the field a choice. And so with the bigger diameters, we can move with longer length of runs, of course. So additionally, we have different wall thicknesses. Obviously, that depends on the actual condition, seasonal, perennial. We'll take a deeper look at that in the next slide. But it's possible to have a good choice, if you will, for the condition that we are making the recommendation for. In terms of manufacturing, we have a production site in Mexico, France, and Australia. From these 3 plants globally, we are supplying all our markets very successfully. Back to the wall thickness, without getting into too much detail here, but obviously from the grower's perspective, they have a big interest to down gauge. So using the thinnest possible material that is applicable to the given situation. So typically with short season crops, 4, 5, 6, 8 mil is common. And it does depend on soil texture, if there are any stones or even rocks, if I may say, hopefully not. And then also tillage practices. So the final tilth of the soil, crop residues. So you've got this regenerative farming with no-till, strip-till, etc. So all of this plays a role in making the right choice of the thickness. But always bear in mind that at Rivulus, we're very effective and efficient on the low mill scale. So this is our game. This is where we flourish and we do well and we excel at. So for the grower, it's important to have a competitive price for that closer emitter spacing, especially when we get below 12 inches. And the benefits of that is, first and foremost, there is redundancy in case of drippers blocking for any unfortunate reason, especially when you've got high value crops. The other important component to that is the faster wet up time. So when you switch on the system, you can wet up the profile much more efficiently. And then as a result, you can have less deep drainage. And this is true, especially in sandier soils. And again, just to reiterate, the double thickness on the seam, giving us that strength, easy to install, easy to retrieve, but also in some instances, allowing us to down gauge compared to our competitors. Some of the questions about the methodology of how we build our product, the blown film where we make the plastic film for the different models and thicknesses, etc. The idea in the blends is to have a product that instead of stretching, it snaps. If you're installing T-tape and it breaks, you need to go and look at the installation equipment. Something's wrong. And the idea behind this is not to have stretching to the point where you actually impact the the flow channel, if you will, or restrict the flow path. And that's a very important consideration. And then again, in the mix here, having those wide range of configurations, the flow rates, the different diameters, and the ability to choose those different wall thicknesses, and very importantly, that emitter spacing, having high density crops, sandy soils, being able to bring that emitter very close to improve that soil distribution uniformity. Having looked at the drip tape or the lateral, if you will, I'd like to just give you some pointers on installation observations and considerations. So very important is we need to understand that when we install and how we install will impact the irrigation proficiency. So the whole system in the final analysis is very dependent on where we put that lateral. And I really believe this is an important message to pass on to you folk today. The positioning in terms of soil moisture distribution in the active root zone, varied. You can see here 2 to 4 inches works well in annual crops, sometimes deeper depending on tillage practices. So weeding, if it's mechanical weeding, you need to make those considerations as well. But then also the installation equipment setup should be such that it enables those lower wall thicknesses to be used to give the growers those benefits on not having heavy gauges. So on the lower gauges, they have less labor time switching over the reels, etc. Then the travel of the tape from the reel into the soil is very important, and I'll show you that in a couple of slides here. But the placement accuracy, the positioning is really one of the takeaways I'd ask you to focus on for today's discussion. In terms of the installation tool per se, you can see here, ideally, we want to have a minimum distance from the bottom of the reel to the inlet or the guide rollers, depending on the manufacturer. We want to have a minimum of 28 inches or 70 centimeters. That is because of the angle the tape is coming off the reel into the inlet. And if that angle is too aggressive, it can create wear on the edge of the tape during the installation process. Even on reputable manufacturer inlets, you've got to watch this edge here. On this particular instance, I ran my finger and almost could cut the skin. So if you run, we call it the pantyhose test. If you run a stocking through here and it it snags, that's not a good installation situation at all for the lower mill products that we're talking about. So just to show you here, you've got the real distance very short going into these guide rollers. So although these move, the rollers turn, that's very, very good when they're new. But as they get old and they slow down, you start to get friction. And then you get this kind of situation here. If you can see this on my slide, you can see how the tape's even folded, bent. So potentially you've got problems before you even switch on the system. So these are very elementary, I know, but these are observations we're seeing today out in the markets, and it's important to highlight that. Another critical point is the positioning. So the lateral placement. This is a game changer in terms of the impact it can have on the plant and the crop. And if the laterals are not well positioned, in the case of double rows and a single lateral, exactly in the middle and well placed, to be able to then exploit that capillary and get that moisture out into those root zones. What you find is, as you can see in this image here with the tomatoes, you can see these plants are slightly smaller than the plants on the right. So I would assume they're getting too much water, whereas these are probably getting the right amount of water. But when you visually see these differences in the field, you know you already lost something. And it's unnecessary. It's only a question of where to position the lateral or the tape. Here on the strawberry beds, we found that you had the same thing happening. So on one side, you'd have more vigorous plants than on the other side. And in fact, on these beds, you've got two laterals. So you've got two tapes under the mulch. But the problem is those tapes are running on the soil surface, so between the soil and the mulch. And when you have condensation, the tape is sticking up against the plastic. And when the wind blows, it moves the lateral sideways. And when that happens, you're getting displacement, or let's say not a very uniform position of the laterals. So these are very simple things to fix. And I really want to encourage, those of us who are out there and have the ability to message this out to our customers, we should be doing that. So in summary, we really want to understand the significance of the irrigation efficiency is highly dependent on that positioning I've been talking about, and in context of applying water in the preferential uptake zone of those target plants. I just threw the slide in here from a recent experience and a field visit. I wanted to share this with you folk. Again, when you see issues on flow rates, any constriction because of the hookups or valves on the lateral that are not fully open, you can see here in this image. It doesn't look like a lot, but it has a big impact on the flow rate. Any of this kind of stuff, again, it's elementary, and I know on a big scale, big operation, this is not easy to manage, but one really does need to take care. And these are the things that can make a difference of having an average crop or an excellent crop. And it's our job to make sure that our customers get the most they can out of what we're recommending. So in summary, what I'm really messaging here is we want to be focusing on promoting hydraulics for agronomics. We want to be able to meet the crop water requirements, answer that question, how much and how often should I be applying water, remembering that changes according to soil type, different growth stages, etc. We want to give professional solutions for soil moisture distribution uniformity. And we want to have the hydraulic capacity in our system design that we can match those ETCs, give the plant what it needs in terms of water demand. We want to be able to do that maintenance, backflush those filters, keep them clean, flush out our laterals, avoid plugging, and then also be able to do our fertigation, meeting the crop nutrition demand. And all of that links into the lateral placement. So making sure that the way we do it, we're covering that active root zone, and we have that functional throughout the whole season of the crop. So as professionals in the industry, we have a very high accountability in the recommendations we make. The grower's success depends on our recommendations, and we really want to be promoting systems that are capable to meet those crop requirements. The system functionality for the crop cycle duration, whether it's a permanent or perennial installation or a seasonal installation, it's no less important to meet these standards when we're making those recommendations. So going to our website, I just wanted to share with you this slide. We have what we call the Knowledge Hub on our website. There's a lot of specialist irrigation topics in there, giving advice to growers, to professionals in design and recommendations. There's a focus on close emitter spacing, crop insights, how to optimize your irrigation system. And then, of course, you have an irrigation expert in your vicinity. Call on them, allow them to give you support and advice as needed. Oops, sorry, I didn't. No. Sorry, guys, I clicked on that link and I didn't mean to. But anyway, that's not going to affect us here. Okay, so that brings us to our Q&A, and I'd like to thank you for your attention and hand it over to Romeo for any questions that we may have here. Please, Romeo.
Yeah, thank you, Ralph. Before I start to read the questions that I already have, I want to remind the participants that there is a special button dedicated to the Q&A section on the lower part of the screen. So if they want to address the question, they should just click on that and address the question, and I will read it out loud. So let's address the questions that we already received. Could the low flow configurations be more susceptible to clogging?
So indeed, so for the different flow rates, there are specific filtration requirements by the manufacturer. So it is important to follow those requirements. So yes, you need to consider, especially if you're going from medium flow down to ultra low flow, you're going to have to step up the filtration requirements.
Okay, the next question is related to EC. So what methods are recommended for balancing EC levels to optimize fruit taste and shelf life?
So every, or let's say each different type of crop has a recommended EC threshold. And so what's important is to be able to measure that. There are EC sensors that are embedded in some of the soil moisture sensor solutions that are on the market, but there are also probes that are specific EC and also pH meters. They're handheld. They can go down, to 12 inches or more even. So depending on whether you want to use a data logger and measure the EC over time, or you want to take spot measurements out in the field, but there are EC meters available.
Okay, we have here a question about clogging. So what maintenance strategies are most effective to prevent clogging and maintain lateral performance?
So what's important here is we need to first and foremost understand the water quality, make sure that the filtration recommendation is suitable for that specific water source. So essentially to make it a bit easier to understand, if we're talking about groundwater versus surface water, in most instances, surface water would tend to have higher biological contaminants at different stages of the season. And that contamination load can build over time. So what is commonly recommended in that instance would be sand media filters. There are also for lesser or where it's expected to have lesser contamination, very good self-cleaning screen filters. So there are different solutions for that. But it starts off with the water analysis and have an expert do the interpretation and the recommendation. That would be my advice.
We have another one on the SDU. So how do you determine the ideal SDU for different crop types and soil textures?
So soil type would be the first consideration in conjunction with plant density. So I'll give you an example. If we're doing leafy vegetables, lettuce, for example, we'd want to have very good soil distribution uniformity down the rows. And we'd be looking at, for example, if we have higher clay, we may not choose to go wider on the emitter spacing because there's a higher clay content. We'd want to keep that emitter spacing close to make sure we get the right distribution to every plant. But the way we regulate that is then changing the flow rate. And as we've said earlier, when you change the flow rate, you've got to respect, of course, the filtration requirements for those emitters. But this is the way that you can match the requirement for soil moisture requirement for the plant in a given type of soil and with a specific configuration of lateral.
Yeah, we have a couple more. So one is regarding the trade-offs between installing a high efficient hydraulic system and keeping the system at a lower cost. What are the trade-offs?
So at the end, it's about efficiencies. And I always say if the cost of the solution is less than the cost of the problem in this case is how much is the grower losing in efficiency and value in quality of the produce they're taking to market because they didn't have a professional or proficient irrigation system. That's the way to understand what are the trade-offs. So it always comes down to money, right? If they're losing money, they feel the pain, they're going to make the change to improve.
Yeah, thank you, Ralph. Ralph, one last question here, and I want to thank the participants for addressing this interesting question. So, can you provide example of successful fertigation schedules tailored to specific phenological growth stages?
Oh yeah, absolutely. So depending again on the crop and the type of crop, but if you take, for example, processing tomatoes, strategizing the pre-plant, so the percentages of NPK that you would have to put down at pre-plant, at planting, and then what you'd fertigate. So you'd break it down into weeks, and you'd then have recommendations by week of how much of the different nutrients need to be applied. But then also the forms of nutrients. So specific to nitrogen. So ammonium-based fertilizer are typically less expensive, so more affordable than nitrate nitrogen. So when is the switch over? So again, if you don't switch over to nitrate at a certain stage, so it's particularly when you're filling the fruit and you're trying to build good quality fruit, you're going to have excessive amounts of for example, ammonium ions in the plant. And those ammonium ions will displace potassium, magnesium, and calcium, which are the key drivers for quality. So the taste and the shelf life. So not that shelf life is important for processing tomatoes, but for fresh tomatoes as it is for strawberries. So it's about having a strategy and having a clear strategy before you put the seedlings in the soil, and then aligning your system design to be able to deliver those strategies.
That is all, Ralph. Thanks.
Well, I saw a question about the presentation. We are going to have a version available to our audiences. So yes, the answer is yes. We will make that available. So that said, I'd like to thank everyone on the call here today. Thank you for participating. I hope it was useful, and wishing you great success in helping growers make the right choices. And T-Tape, the best by far. Thank you.